Screens. We all have screens at our home, at our workplace, or wherever we go, we see screen. Heck, you're even watching me on a screen. Now let's get back into the history of screens. So the first ever screen was made by this guy named Carl Ferdinand Braun. So he created a screen using CRT, also known as cathode ray tube, which was commercialized in 1922. Now let's understand how CRT works, how the principle is and everything. I'm gonna be technical in this, but it is what it is. So CRT consists of an electron gun which shoots electrons on a phosphorus coated display, and then you see a series of images or video. Now this CRT could only show you series of images or video only in monochrome. For the guys who don't know what monochrome is, it basically is black and white images. But then in 1954 they upgraded the CRT and they used more than one electron guns. To be precise, 3 electron guns, which were red, green and blue, meaning RGB. That's why we could see 3 different colored dots when we see a display or a TV from nearby. And then 29 years later, monochrome plasma displays were introduced by IBM. You guys might have seen these kinds of displays in the recent series of WandaVision. A plasma display panel or PDP is a little different from CRT displays, as it is a type of flat panel which has tiny cells between the 2 glass panels, which hold the mixture of noble gases, that is neon and xenon. Now these gases are electrically turned into plasma, which then excites phosphorus coated screen to emit light. But it was not that flat when it was introduced in 1964. And also, these monochrome displays were not RGB, they were orange, green and yellow. And it gained popularity over the years till the 1970s, as it did not needed any memory or any circuitry to refresh the images. Now these kinds of displays are capable of producing more deeper blacks than LCDs, which I'll come to in a bit, which means these kinds of plasma displays were able to create more contrasting images. But these displays did not have much of a sale after the 1970s because the CRT displays became cheaper. But then in the future, a little bit more thin plasma displays became popular. Now the problem with the phosphorus coated displays, which were used in both CRT and plasma screens, is that the phosphorus compounds that emit light used to lose their luminosity when used over a longer period of time, which hence resulted in a muddy kind of image. So liquid crystal displays, or also famously known as LCD, was introduced, which had light modulating properties of liquid crystals along with polarizers. Now let's understand how polarizers works. So how a polarizer works is that it allows a certain light waves to pass through these polarizers and also blocks some light waves to pass through. Now these liquid crystals do not emit light directly. Instead, they use a white light or a reflector which goes through these polarizers, and then you see a series of images which may be in monochrome or in color. LCD displays were one of the main reasons to have portable computer, as these CRT displays and plasma displays were thick and really heavy to carry from one place to another. These LCD displays were under research and development from 1960s to 1990s, and in 2000 to 2010 it gained popularity as it surpassed the image quality of cathode ray tube, I mean CRT. In 1962, the first ever light emitting diode or LED was invented by Nick Holonyak Jr. while he was working in General Electric Company. The first ever LED displays was commercialized in the late 1960s, but the display emitted red. I mean not monochrome, not RGB, red. So obviously not many people bought it. But then in 1994, a Japanese scientist named Suji Nakamura demonstrated efficient blue, white and green LEDs, laying the foundation of the LEDs revolution. A revolution we have seen in lighting and display technology. Now an LED display consists of closely spaced LEDs. So instead of using a white backlight, they used LED backlights. By varying the brightness of each LEDs, the diodes jointly form an image on the display to create a bright color image. Now these 3 colors combine to form a pixel. By adjusting the intensity of the diodes, billions of colors can be formed. Now you might ask why only these 3 types of colors are used. The only reason is because when you combine these 3 colors, different colors can be formed other than red, green and blue. Since 2012, organic LCD displays are in the market, also famously known as OLED displays. They emit their own light and color. Now how do they emit their own light and color is by using a film, a carbon film that sits inside a panel behind a glass screen. The colors are even more vibrant because they are coming to you directly. not like the LCD and LED screens in which they had a backlight through which you could see the colors. Now these OLED displays uses organic materials which are really expensive. So very limited companies like LG is making these kinds of OLED displays, and other companies are getting into it, but they are gradually coming into it. Now there are two more kinds of OLED displays. One is AMOLED and another one is QLED. Active matrix organic light emitting diode, also known as AMOLED. Now these displays on the other hand consist of a thin film transistor or TFT over the OLED displays, giving it a better use in the larger displays. Now this is an advancement of OLED technology which requires less energy to produce the same quality as a traditional OLED display. So they can be used in more sizes, but for now they are only being used in mobile phones. I mean high-end mobile phones, and this can potentially be used till 8K resolution displays. Now let's talk about quantum dots or QLED displays. Now these QLED displays were in the market from 2015, and QLED displays are similar to OLED displays. I mean they are flat, but making is a bit different. Quantum dots are microscopic molecules that when they are hit by light, they emit their own differently colored light. In QLED TVs, the dots are contained in a film and hit by a backlight. That light travels through different layers which are inside the screen, including the LCD display which is inside the screen. And surprisingly, Samsung is researching on this technology which dispenses with the liquid crystal layers and uses quantum dots themselves as a light source, just like in OLED displays. Now there is one more kind of OLED display which I did not talk about. Well, it is actually in a research and development time, and some of the companies is producing it. Well, that is transparent OLED displays. Now how these OLED displays are made is by using couple of plastic layers which is sandwiched between two layers of glass consisting of emissive and conductible layers, and then when the electricity is passed through it, it produces images. Now this kind of OLED screens are only being used on TVs and is only being produced by Xiaomi and LG. But in near future or in future, we hope, or I hope, that we see these kinds of transparent screens on our TV, on our watches or any electronic accessories or devices, because this thing is freaking futuristic, man. So why different kinds of displays in this era? Well, the simple answer to that is it's not like the displays are going out. They are still in the market and they are being sold, but are slowly getting out of the demand and also getting finished as better displays are being made, researched and developed. So that's it for today, guys, and I hope you enjoyed this video. Catch you guys in the next one. Peace.